shall we now talk about the square root of 2? You mentioned that as an example of an irrational number.
Well, why don't I erase the board quickly?
Okay.
So when you talk about the square root of 2, and the first place I saw this was I took a real analysis class this past year, and it's like the first example you look at in a real analysis class, and it's pretty interesting. What I'm going to do here is use something called proof by contradiction.
Okay.
So I'm going to assume something is true, and then we're going to do some math, we're going to do some very basic operations, and we're going to arrive at a contradiction. So once we arrive at the contradiction, we can now know that what I assumed was true is actually false.
Right, because you're starting with that initial premise.
Yeah.
You use logical deductions to find more and more implications from that initial assumption, and you arrive at some conclusion that you know is false. And by virtue of just retracing back your steps, if this is false, then that initial assumption must have been false.
Exactly.
Right.
Exactly.
Okay. So we're going to show that the square root of 2 is an irrational number.
Yes.
So we're going to start then. I'm assuming that we'll start with the premise that the square root of 2 is a rational number.
That is correct. Okay. So we'll write square root of 2
equals P over Q.
Where P and Q are integers. And Q cannot be 0.
Q can't be 0. And any fraction, it can be represented in lowest terms. So we're going to say P and Q are in lowest terms. Because any fractions have got to be lowest terms.
So let me just write that, because that'll come in handy.
Okay.
Sorry for my handwriting.
That's right. That's right. We understand. We can see this. Okay.
Okay. So square root of 2 equals P over Q. So we're now going to do some operations which are pretty logical, nothing controversial.
Yeah.
And we'll arrive at some sort of contradiction.
Okay.
So I'm going to square both sides of the equation.
Okay.
Okay. So I'll just write it out just so it's clear what's going on. So square root of 2 squared equals, let's go P over Q.
Okay. Handwriting's really bad. The square root of 2 squared equals P over Q squared. Let's
simplify that. So 2 equals P squared.
Sorry, David. Would you mind writing it a bigger?
Okay, yeah, let's write.
I think we can read it, but we just need it to be bigger, just so that it's visible. Good. Yeah.
Yeah, that's much better.
And just for everybody, that was a Q over here. Yeah.
Okay. So we'll multiply each side by Q squared. I think that's also reasonable.
Yeah.
Okay. So now let's look at P squared for a second.
Yeah.
So P squared is equal to 2 times Q squared.
Yeah.
What we're now going to say is that P must be an even number. So look at this. If you have an even number, you multiply it by itself. It's going to be an even number. If you have an odd number, you multiply it by itself. It's going to be an odd number.
Yes.
So we have 2 times Q squared. I don't care what Q squared is. I know 2 times it is going to be an even number.
Yeah.
And then this implies P squared is even, therefore P is even.
Okay. Right. So if you have, if P squared is an even number, then P has to be an even number. Can you explain that last step? I think I and everybody can understand that 2 times P squared must be an even number, but that last step, why must P be an even number?
Well, you could just look at it by example, right?
Okay.
So what's the product of 2 odd numbers?
It must be an odd number.
Must be an odd number.
Right.
You can find
Yes, you know what? That's actually write this out. I think that's a really good way. So if you have an odd number squared, that has to be an odd number. We know this. Okay?
Yes.
That has to be odd. Okay. Now if we have an odd number, multiplied by some even number,
that's going to be
has to be even.
Yeah.
Right. Okay. Now, if we have an even number multiplied by some even number,
yeah,
that has to be even.
Yes.
Okay. And if we have an even number multiplied by itself, it must be an even number.
Right. Okay. Because they're both even, right?
Right. Okay. Okay. Yeah. Okay. Yes. Okay. That's clear enough. Okay.
Okay. So I'll maybe write over here that P is even. So actually, can I erase the top part, just so we're keeping track of what's going on.
Yeah.
So we'll use the therefore. Let's go.
P is even.
Okay, P is even. Now, if P is an even number, we have two cases here.
Yeah.
Either P is some odd number times 2, or P is an even number times 2.
Yeah.
So let's take a look at this. So let's say, just as an example, like let's say P is 6. Well, that's obviously 2 times 3.
Yeah.
Let's say P is 8. Well, that's the same as 2 times 4.
Yeah.
Okay. So would you agree with me that P being even means that P equals, let's say, 2 times K. And just K is some integer.
Yeah.
Something like that.
Yeah.
Okay, would you agree with me with that?
Yeah.
Okay, well, we now have this fact. So why don't let's sub in 2 times K into this part of the equation.
Okay.
So 2 squared equals. We'll simplify it and just expand out what that means. So equals 2. So 4k squared, and we'll do another uncontroversial thing. We'll divide by 2.
Right.
Do you see what the problem is here now?
Okay, so we know that Q it has to be an integer. And we assume that the square root of 2 is a rational number.
Right.
Now, okay, so Q squared divided by K squared is equal to 2. Now, if I then take the square root of both sides, I'm going to get Q over K is equal to the square root of 2. Now, is that a problem? Let me think. Okay, so we know that K is some integer. So we start by assuming that the square root of 2 is a rational number. So I can't quite see the contradiction here. I need your help.
Okay. And you know what? I almost asked you just a little too early, because I think if I wrote this right away, you might have seen it.
Okay.
Q squared equals 2k squared.
Yeah.
Let's use the same logic we used up here.
Okay. So Q must be even.
Yeah. And let's say, I don't know, let's say 2j.
Sure, 2j. Okay.
2j. Okay, originally, the square root of 2, and we ended up erasing it.
Yeah.
We said the square root of 2 can be represented by 2 integers, p over q.
Right, so this is represented in lowest term. Okay.
Okay, so square root of 2 equals p over q. We picked the lowest terms version of that.
Yeah.
We know that p's even, q's even. Well, what we have here is equals p over q equals
2k.
Right.
When you look at that, does that look like it's in lowest terms?
No, because you can divide 2 to get k over j.
Exactly. So obviously,
you can divide 2 on top and bottom. Excuse me. Yeah.
So we go back to here and we say, wait a sec. This must have been wrong, right? There is no representation. P over Q or P and Q are integers,
right? Where
they're in lowest terms,
right?
Therefore, square root of 2 is not rational. Right, we can't describe it using fractions like this.
Right. Okay. Right. So if a fraction is in lowest terms, is in the lowest term, you cannot divide by some integer on the top and bottom to get it an even a smaller number on the top and bottom to represent the same fraction.
Yeah, but it has no. I think the term is no prime common factors. Basically,
okay.
So they don't have any common factors. It's in the lowest terms. Clearly,
right. Clearly, that's not the case. So this right here is a contradiction.
Yeah.
Okay. Okay, so therefore, the square root of 2 is not represented by some fraction p over q, where p and q are integers.
Right.
Okay.
So if it can't be represented by a fraction, remember our definition of what irrational numbers were.
Right.
Numbers that couldn't be represented by a fraction.
Right.
It's got to be an irrational number.
Okay. That is a pretty neat proof. Yeah. Thank you for showing this to me. This is pretty cool.